A very good morning, students. In today's class, I'll be talking about density of a solid. Solids are basically classified into two categories, amorphous and crystalline. I am going to talk about the density of a crystalline solid. We would be talking about crystals of elements, which means a solid which is crystalline but is made up of only single type of atoms. Could be an iron crystal, could be a copper crystal, could be a lithium crystal, so on. Not about the compounds. Any crystalline solid is an ordered arrangement. And its building block is a unit cell. In our course, we would only be talking about cubic unit cells. And a cube is something which is a three-dimensional picture of this kind. A cube is our unit cell, the basic building block of the solid state, which is crystalline. This is the edge length of the cube and we refer to it as A. This is generally given in the units of picometer. In our syllabus, we have got unit cells of three categories. The first being simple cubic unit cell. The second being body-centered unit cell. And third is face-centered unit cell. In a simple cubic unit cell, the number of atoms present inside the unit cell comes to be calculated as 1. Whereas in a body-centered unit cell, the number of atoms inside the unit cell as calculated comes out to be 2. And in a face-centered cubic unit cell, the number of atoms inside the unit cell is calculated to be 4. These three values are also written as Z, which is equal to number of atoms in a unit cell. I'm not going to the details of how do we get these numbers because we are presently talking about the density of a solid. Moving on to the density, before I actually start with this, at times body-centered is written as BCC, face-centered is written as FCC. This can also be written as HCP or CCP, so don't get confused. If it's written hexagonal close packing, cubic close packing or face-centered cubic, you would take your Z value to be 4. Moving on to the topic that I'm going to do today is density. When I talk about the density of a solid, that too a crystalline solid, then our interest is in the unit cell. Since it's an ordered arrangement, if I'm able to find the density of a part of the unit cell, the density being an intensive property, that is the property which is not dependent on the mass. So any amount of crystals that you have, if you know the density of a part of the crystal, the density of the whole crystal remains the same. On that fact, we conclude that if you know the density of the unit cell, which is the building block of the crystalline solid, the density of the solid is same. So when we talk about the density of a crystalline solid, we actually talk about density of unit cell. When we talk about the density of a unit cell, when it is the mass of the unit cell divided by the volume of the unit cell, where UC is the short form of the unit cell. The mass of the unit cell and the volume of the unit cell. As you know, the volume of the unit cell would be by the cube, which is your unit cell, and the volume of a cube is nothing but edge cube. Hence, the denominator in this case can easily be understood as A cube, where A becomes your edge length. Density, I'm taking it to be D. The mass of the unit cell. For the mass of the unit cell, you need to know how many atoms are there. The number of atoms is decided by the type of crystal that we are talking of. So this is the number of atoms. Plus, what is the mass of each atom? To get the mass of each atom, you require the atomic mass divided by the Avogadro number. So this part capital M divided by Na, where capital M is the atomic mass and Na is the Avogadro's number. This part actually gives you the mass of single atom. Furthermore, so your formula becomes D is equal to Z, atomic mass, A cube, the edge length, and Avogadro's number. Avogadro's number is 6.022 10 to the power 23. Atomic mass would be provided to you. The values of Z can be 1, can be 2, can be 4, depending on whether it's BCC, FCC, or it is a simple cubic unit cell. A. There's a slight problem in this. Normally, your density is given in the units of grams per cubic centimeter. Since it is given in cubic centimeter, your A should be in centimeters. Generally, it is given to be in picometers. So in that case, you should know 1 picometer is equal to 10 to the power minus 12 meters. You don't require the meter, you require it in centimeters. So it becomes 10 to the power minus 10 centimeters. In case it is given in Armstrongs, then 1 Armstrong is equal to 10 to the power minus 10 meters. You don't require meters, so the value is 10 to the power minus 8 centimeters. This is the requirement. So the concept of density of a unit cell is related to the density of the solid. Since it's a crystalline solid, the density of a unit cell will be reflected in the density of the solid itself. To get the concept a little more ahead, I'll be taking an example and a numerical to make the concept a little more clearer. Moving on to the first numerical. Let's go through the numerical. An element crystallizes in BCC. That's given to you. The edge length, that becomes your A value, of the unit cell is 288, it's picometers. So you need to convert. The density is 7.2 grams per centimeter cube, which means your length has to be in centimeters. You are supposed to find the atomic mass. The formula that we'll be using is density is equal to number of atoms in the unit cell into atomic mass upon A cube and Avogadro's number. In this formula, you are provided with the density 7.2 grams per cubic centimeter. Atomic mass is to be found. Avogadro's number 6.022 10 to the power 23. Your A value is 288 into 10 to the power minus 10 and then a cube on top of it. Whereas your Z value, since the unit cell was given to be BCC, this value comes out to be 2. Substituting these values to get the answer for your atomic mass, the formula modifies into density A cube, Avogadro's number divided by your Z. Substituting these values, you get the answer as density is 7.2, Avogadro's number is 6.022 10 to the power 23, A cube is 288 into 10 to the power minus 10 whole cube divided by Z, which is 2. On solving this, you would get your atomic mass, which ultimately will give you 7.2 into 6.022 into 288 3 times, and your power of 10 is 23 and minus 30, which makes it 10 to the power minus 7, and you need to divide it by 2 also. On calculation, you would end up in an answer which comes out to be 51.77. Now, either you report it as U, the unified mass, or the same answer can be reported as grams per mole. Don't forget, if the units are incorrect, you lose your marks. So either it has to be unified mass or it has to be grams per mole. I'll take the concept a little further with a second numerical. The second numerical is as given. This time the element in FCC structure has a density of 7.2 grams per cubic centimeter. If 4.12 10 to the power 23 atoms of the element are weighing 200 grams, you are supposed to calculate the edge length of the unit cell, which means A is the requirement, FCC gives you the Z value, density is provided to you. So the formula remains density is equal to number of atoms in the unit cell, atomic mass, A cube, the edge length whole cube, and Avogadro's number. If you recall, I had told you this value actually gives you the mass of single atom. In this question, as you can see, the capital M is not given and edge length is asked. So two parameters you cannot find, which means there's a catch in it. What you can do is this factor where you are taking the atomic mass divided by the Avogadro's number, it actually gives you the mass of the single atom. The information in the question is these many atoms weigh 200 grams. Therefore, the mass of the single atom for this question can be calculated as 200 divided by 4.12 10 to the power 24 is this particular parameter, which will give you the mass of a single atom. The density of the question is 7.2 grams per cubic centimeter. A is to be found and Z according to FCC would be what? 4. Substituting the values, the formula is to be changed. Your A cube is Z M by Na and density. Substituting the values, A cube comes out to be 4 is the Z value. Instead of M by Na, I am using 200 divided by 4.12 10 to the power 24. Your density is 7.2. On calculation of this part, you end up in a value which is equal to 27 approximately into 10 to the power minus 24 is your A cube. If you need the value for A, you need A therefore is equal to 27 into 10 to the power minus 24 to the power 1 by 3, which becomes 1 by 3 under root, this is a cube root of 27 becomes 3, and the power of 10 automatically divided by 3 becomes minus 8. So that is your answer. Don't forget the units. Since the density was in grams per cubic centimeter, your edge length comes out to be in centimeters only. The last numerical is this. Lithium metal crystallizes in body-centered cubic. Density is equal to Z M A cube Na. Density of the question, lithium is crystallized BCC, which means this becomes 2. Density is 0.53 grams per cubic centimeter. Atomic mass is also given 6.94. Na 6.02 to 10 to the power 23. Calculate the volume of the unit cell. Now, what is the volume of the unit cell? A unit cell which is a cube. The volume of a cube is edge length cube, that is A cube. So this is your question. Hence, this is to be found. Rearranging the parameters, A cube is equal to Z M T by Na. Substitute the values. The values are 2 for BCC into 6.94 divided by 0.53, the density, into Avogadro's number. On calculation, you would end up in the value of A cube to be 4.33 into 10 to the power minus 23. I am using the calculator. I am not that quick at maths. So it's 4.33 10 to the power minus 23. And the units would be what? Kya dalenge units? A cube has to be centimeter cube is your answer. Thank you.